Hello everyone. The title of this video is Multiplying Complex Numbers. Now each example I'm going to be doing from this video is taken directly from a free online textbook at openstax.org, and I'm in their Algebra and Trigonometry text, section 2.4, titled Complex Numbers, and I'm under the objective heading Multiplying Complex Numbers. So each example will be either an example from the reading or a try it problem from the reading, or from the exercises at the end of the section that are related to this particular objective, multiplying complex numbers. And I would request that whenever I bring up a new question, you pause the video and try to work out the problem yourself first before watching me doing it and comparing, because you should be practicing these on your own as well. Great, so the examples I have written out on paper. So again, we're asked to multiply and simplify these complex numbers. Alright, so one of my tips for you to start this, and I also said this in the adding and subtracting complex numbers video, is treat the imaginary unit. Remember I was the principal square root of -1. Treat it as a variable, even though it is not. Right, treat it as a variable. But also recall that it's not a variable, and recall that whenever you see I to the second power, right, if you ever see I squared, remember that's -1. So anytime you see I squared in this, replace it with the real number -1, right? That's how I was defined, a number that you can square to get -1. So keep that stuff in mind. And then you would just multiply the same way you would multiply polynomials. Multiply the way you would multiply polynomials, right, with lots of distributing and combining like terms and whatnot. Okay, so I'll just write out a general multiplication of complex numbers. So remember, the standard form for a complex number is a plus bi. Right? This was the standard form for a complex number. You had a real part plus an imaginary part, a and b. These are real number plus imaginary number. And say we multiply this by another complex number, c plus di. So remember how to multiply. These are two expressions with two terms. You can call it foiling if you want, but remember how to multiply polynomials, right? You take two at a time, like I have here, and you take each term from one of them and distribute to the other, and then combine like terms when you're done. So first I'll distribute the a, and we would get a times c plus a times d times I, right? So a times d times I. So again, real number, a times c, there's no I attached, plus here's an imaginary number, right? A times d are real, but then you have times I, which makes it imaginary. Right? All right, now I'm done with the a, and then you move over and take the bi and distribute that. Right. So then we have plus, b times I times c, if I rearrange it, is b times c times I, but it's imaginary, right? It has I attached to a real number. bc is real, but then the times I makes this term imaginary. And then finally we have plus, b times I times d times I. That'd be b times d, and then I times I is I to the second. Right? You have two factors of I squared there. But wait a minute. Remember what I said earlier. I is not a variable. I is a number. I squared, whenever you see I squared, that's -1. So really what we have here is a times c plus, a times d times I plus b times c times I. And then this last term becomes a minus, right? I squared is replaced with -1. So it's b times d times -1, or just minus bd. And then you combine like terms, right? Combine real numbers with real numbers. So the new real number would be AC minus BD. This is the real term of the final result in standard form, right? You should have a real number plus an imaginary number at the end, right? In standard form for a complex number. Plus, and then combine the imaginary numbers, and just add their coefficients, right? You have AD plus BC times I, right? And this is our final result, right? When multiplying two complex numbers in standard form. And again, your final result should also be in standard form, a real number plus a real number times I, right? A real number plus an imaginary number. All right, now for this first example, I know I don't have it, it doesn't look like this, but it technically is. Right? Now I'm not gonna foil this, but example 1, you have 1/2, which you could think of as 1/2 plus 0i. Right? That's if a number is strictly real, then the imaginary part would be 0. Right? Now 1/2 is the same as 1/2 plus 0i. And then you have times, this other complex number with a real part of 5 and an imaginary part of -2. Right? That's 5 minus 2i. And then you could do the foiling if you want. You could do everything I did over here. Right? But this is silly. Right? There's no reason to add 0 to anything. Right? So I'm going to ignore what I just wrote here. But you could if you wanted. Right? If you wanted. All I have here is a single term expression times a two-term expression. We're just distributing. Distribute the half to both these terms. And that's all, right? So we end up getting, a half times 5. That would be 5 halves, or 2.5, or 2.5, right? And then minus, and then 1/2 times 2 is 1. So you just have 1i. Right? So there's your real number, 5 halves. And plus, there's your imaginary number, -1i. Easy, right? Very simple, especially, when one of the numbers is only real, right? There's only one term, or if it was only an imaginary number, there'd still only be one term, and you'd be just distributing that one term. Now, if you'd like to check this with technology, you can. Right? There are calculators out there that deal with imaginary numbers, and I've shown this in the previous video on adding and subtracting complex numbers. Here I have an emulator for the TI-84 Plus. The TI-83 and 84 are very similar. And if you look at the top, I'm in A plus BI mode, right? I'm in complex mode, so I can deal with imaginary numbers here. If you're in real mode, and you want to deal with imaginary numbers, you're going to have to change it to this A plus BI mode, right? Just hit the mode button and find it. So yeah, I'll just enter what we had. We had 1/2, 1 divided by 2, times the quantity 5 minus 2i. Now the I is above the decimal point here. See, and I should end up with 5 halves minus I, or 2.5 minus I. Look at that. That totally works. That checks out. It looks like we did a good job there. All right, cool. All right, so I'll clear this. Get rid of the calculator. I'll check a few of these. with a calculator, but you don't have to. If you feel confident that you are doing things correctly, distributing and combining like terms correctly, you probably don't have to do all that much checking. Great. All right, now example 2 is like what I wrote over here, right, where both of the numbers have a real number and an imaginary number in it, right? A real part and an imaginary part, just like I had over here. So here I'm going to be doing the FOILing, right, or lots of distributing. So we have 3 minus 4i times 2 plus 3i. So first I'll distribute the 3 to the 2 plus 3i. So we have 3 times 2 is 6. Next term would be 3 times 3i would be 9i plus 9i. And now I'm done with the 3. And I move over to the, now don't forget the negative. Right? Negatives are part of terms. We're distributing negative 4i to the 2 plus 3i as well. Negative 4i times 2 would be negative 8i. And then negative 4i times positive 3i would be negative 12i squared. But don't forget, I squared is really negative 1, right? So this becomes 6, plus 9i minus 8i, and then negative 12 times I squared. Negative 12 times negative 1 is plus 12. Right? And it becomes a real number, no more I in it. All right, then we combine like terms. The real numbers are 6 and 12. Those add up to 18. And the imaginary numbers are positive 9i and negative 8i. Combine those, you get positive 1i, or just plus I. Right? So the final result, in the standard form for a complex number, right, real number plus imaginary number, is 18 plus 1i. All right, and once again, I'll check this out with some technology. Pull up my emulator here. And I'll enter the expression they gave us in the beginning. Right, we had the quantity 3 minus 4i multiplied by, and then the other number was the quantity 2 plus 3i. Okay. And we're getting, see, 18 plus I, exactly what I got there. Fantastic. All right, wonderful. All right, so next question, and I'm doing the same stuff for all these. There's a lot of distributing and remembering that just remember that I squared is negative 1 and you'll be fine. All right, so now this time, you got a 2-term number with a real part and an imaginary part, 2 plus 3i, times, and then something that's strictly imaginary. Now you could think of this as 2 plus 3i times, and then 4i has a real part of 0. You can think of 4i as 0 plus 4i if you want, and then do the FOILing and combining like terms and whatnot. But again, adding 0 is silly. Right? There's really no reason, but you could think of it this way. But I'd rather think of it the way it's originally given to me. 2 plus 3i is 2 terms. 4i is just a single term. So just distribute that single term to the other one. Right? I'm distributing the 4i to the 2 plus 3i here. 4i times 2 would be 8i. And then 4i times 3i would be positive 12i squared. But again, don't forget, I squared is negative 1. So what we have here is 8i minus 12. Right? Because you have 12 times negative 1. And, just to put it in standard form, right, the standard form has the real number term first, and then the imaginary number term. So the real number term is negative 12. the imaginary number term is, positive 8i plus 8i, right? This is what the calculator would shoot back, right? This is the standard form. I mean, this isn't wrong either. I mean, 8i minus 12 is fine. It's just, they'll probably want you to put the number in standard form for a complex number, real number plus imaginary number. And once again, let's test this out. Pull up my calculator here, and the first number was 2 plus 3i times, and then just 4i. Look at that, negative 12 plus 8i. Exactly what I got. Doing it by hand. Excellent. Alright, so I'm going to leave the rest of the checking to you if you want to do it on your own. Okay, that'll be the last one I do the calculator for. Alright, so again here we have 6 minus 2i, two terms, a real number, imaginary number, multiplied by just a real number, 5. Now you could think of 5 as 5 plus 0i, right? The imaginary part would be 0, but that would be silly. There's no reason to add 0 to anything. And then just distribute the 5, right? Just one term over the two terms. So this one's easy enough. 5 times 6 is 30, and then 5 times negative 2i would be negative 10i. And this is already in standard form. You have your real number term first, and then your imaginary number term, right? The real part is 30, the imaginary part is negative 10. And there we go. 30 minus 10i is the product of those two numbers. Great. So I got just one more page. So here we have number 5, we have 2 plus 3i times 4 minus i. So both numbers have two terms, right? Both numbers have a real part and an imaginary part that are non-zero. So I start with the 2 plus 3i here. Let's distribute the 2 to the other number, right, to the 4 minus i. Okay, so 2 times 4 is 8. 2 times negative 1i would be negative 2i. Alright, so now I'm done with the 2. Move over to the positive 3i and distribute that. 3i times 4 is positive 12i. And then 3i times negative 1i would be negative 3i squared. Okay, but don't forget, right, I squared is negative 1. So this becomes 8 minus 2i plus 12i. And then this last term, negative 3 times I squared, is really negative 3 times negative 1. It's positive 3. Right, then I combine the real numbers, right? 8 and positive 3 add up to 11. Combine the imaginary numbers, negative 2i plus 12i is positive 10i. And there you go. It's 11 plus 10i. And that's in standard form, right, for a complex number, real number plus imaginary number. And once again, I'll put a little check mark, next to it, reminding you to check your work, double check it, triple check it. All right, and then the final example, same thing. Both these numbers have a real part and an imaginary part that aren't 0. So I'm going to show you how to do this one in a couple different ways. Right? There's something special about this example, but first I'll just go through it like usual, like in example 5. We'll start with this 4 in this first number and distribute it to the other number. Right. So 4 times 4 is 16, and then 4 times positive 2i is positive 8i. Great. Now I'm done with the 4, and let's move over to the, don't forget the negative as part of the term. Move over to the negative 2i. And I'm distributing negative 2i. Negative 2i times 4 is negative 8i. And negative 2i times positive 2i would be negative 4i squared. But once again, don't forget, I squared is negative 1. So what we have here is 16, plus 8i minus 8i. And then this last term, negative 4 times I squared is negative 4 times negative 1. It's positive 4. That's plus 4. All right, then combining the real numbers, 16 plus 4 is 20. And then you combine the imaginary numbers and look what happens. Positive 8i minus 8i, that's 0i. Now you could write it. There's nothing wrong with this. This is totally fine. 20 plus 0i. It's just, as I've been saying throughout the video, adding 0 is kind of silly. It doesn't change the value of anything. So really this is just the number 20. And that's what I'd accept, as the final result here. Now again, you can put 20 plus 0i, there's nothing wrong with that at all. It's just, again, adding 0 means nothing. So this is the number 20. So look what happened here. We have a number with an imaginary part multiplied by another number with an imaginary part. Right? Negative 2i, positive 2i. And look what happens. I end up with a number that has a 0 imaginary part. It's a real number. Right? Strictly a real number at the end with no imaginary part, 20. Well, you're going to see that that's going to happen when you have expressions like this. These are called complex conjugates. And you may have heard the word conjugate before, right? The conjugate of a plus b is a minus b. Right? It's the same terms, but with a different sign in the middle. So let me show you what happens, when you multiply complex conjugates. Right? Say a plus bi multiplied by its conjugate would be a minus bi. Right, so it's just, again, it's like the same two terms, only with a different sign in the middle. Right? So like this, 4 plus 2i times 4 minus 2i, right? So these are complex conjugates. And look what happens, right? You'd have, if I distribute the a, we'd have a squared, and then minus a times b times I. And then I would distribute the bi, we'd have then plus a times b times I, and look at that. These imaginary terms will go away, right? Negative abi plus, abi, that'll make 0i. And then we have bi times negative bi, negative b squared I squared. But remember, I squared is negative 1. So what we end up with here is a squared plus b squared. Right? Which, and no imaginary part. Right? The imaginary numbers add up to 0, 0i. So you see I end up here with a strictly real number when we multiply complex conjugates. And this is going to be important when we divide complex numbers. You're going to see that when we divide by a number that has an imaginary part, we're going to simply use the complex conjugate to turn it into a problem where we're dividing by a real number instead, right? Just strictly real, no imaginary. Right, but that'll be for another video, a video pretty soon after this. Okay, great. So I'm hoping that, simple enough, right? You multiply these things just like you would multiply polynomials, combine like terms, right? Reals with reals, imaginaries with imaginaries. And just remember that I squared, if it ever shows up, is -1. I squared is real, right? It's not imaginary. It's -1 only. All right, and I'm hoping that watching me go through these 6 examples here help you in some way when you're asked to multiply complex numbers and simplify on your own. And thank you very much for watching.